Hi guys, welcome to NEET World Institute and NEET World YouTube channel. And today's topic is electrostatic potential and capacitance. This is from class 12th IPE physics. So this is for both AP and Telangana students. Okay, and this is for short answer questions. Okay, SAQs. Okay, and we will see the questions now. Okay, yeah, let's start with the class now. So the first question of this class is derive an expression for the electric potential due to a point charge. So when we talk about a point charge, like a potential, they are asking about the potential. First we need to know about what is the force. When we talk about the force, it is F is equals to 1 by 4 pi epsilon naught q naught by x square. And let us see what is the electrostatic potential means. Okay, so electrostatic potential at any point in a region of electrostatic field is the work done bringing a unit positive charge from infinity to that point against the electric field. Okay, so it is the work done to bringing the unit positive charge against the electric field is called as electric potential. Okay, like electrostatic potential will say, which is denoted by the letter V. So it is work done by charge, like it's a unit positive charge we will take. Okay, so potential due to a point charge, that's the thing we need to derive now. So we are considering a point charge q at a point O. Okay, charge produced electric field around it. Obviously when I talk about either it's a positive charge or negative charge, like charge field will be there, electric field will be there. So let q naught be the test charge placed at point A. The force acting on the test charge will be F is equals to 1 by 4 pi epsilon naught q naught by x square. So the test charge q naught is displaced towards plus q. Like if we take that, if we take the plus q charge, like it has been displaced towards from A to B through a displacement of dx. So obviously when I talk about the work done, it is nothing but force into displacement. Okay, so why we have taken this as negative? Because it has been displaced towards plus q, right? So minus f into dx. So when we do the differentiation part, integration part, like we need to integrate this one. Like when we integrate x, like w will be, like dw will be the total work we can get. Like this is small work, w will be the total work. So we will get that as 1 by 4 pi epsilon naught q naught by r. Okay, r square in the sense it is a force. When we talk about r, like 1 by 4 pi epsilon naught r q naught by r, okay, is potential we can say, or else 1 by 4 pi epsilon naught q naught by r also potential we can say. Okay, so therefore the potential at the point P, it is 1 by 4 pi epsilon naught q by r. Okay, this is the derivation of the first question, right? You can take a note of this. We'll go for the next question. Done. Can we go for the next question? Okay, so the next question is derive an expression for the capacitance of a parallel plate capacitor. Okay, so a parallel plate capacitor consists of two large plain parallel conducting plates, okay, separated by a small distance. So when we talk about the things, like the parallel plates, it will be looking like this. Yeah, so this is my parallel plates, which is between the distance of d. Okay, So let A be the area of each plate and D be the distance between the plates. The two plates have charge plus Q1 minus Q, right. So this is the thing, right, A and B. So this is plus Q and this is minus Q, distance between them is D. The surface charge density of a positive charge is Q by A, right, charge by area, right now. And the electric field between the plates will be E is equals to V by D, which is nothing but sigma by epsilon naught, we can say. So what is sigma? It is Q by A. So Q by A epsilon naught is the electric field between the plates. So the potential difference of the potential difference between the plate is E into D, right now, electric field into distance. It is QD by A epsilon naught. So when we talk about this as equation 1, and the capacitance of parallel plate capacitor will be Q by V, okay, Q by V. So from these two equation we will get the capacitance C as A epsilon naught by D. So if the medium between the plates is filled, it's filled with a dielectric of dielectric constant K, then it is Ka epsilon naught by D. When we talk about only the capacitance is A epsilon naught by D, when dielectric constant has been filled in between them, no, so it is Ka epsilon naught by D, which is nothing but K times C, we will take it, okay. So this is my derivation of the capacitance, okay, you can take a note of this. Done. Can we go for the next question? Okay. So next question is, explain behavior of dielectric in an electric field. So in polar dielectric substance, charge is not distributed symmetrically. Yes. So that is, the center of a positive and negative charge do not coincide even in the absence of an electric field, right. So when we talk about the things, in a diagrammatic way. So in non-polar dielectric substance, right, the charge is distributed symmetrically. When I talk about a non-polar dielectric substance, like charge is distributed symmetrically, that is center of positive and negative charges coincide even in the absence of electric field, right. Sorry, it is a polar, it will come when a non-polar dielectric field are placed in an external electric field, right. So E naught, in each molecule the center of positive charge will be displaced in the direction of the electric field, and the center of negative charge in the opposite direction of the electric field, okay. So when I talk about a non-polar dielectrics, it has been like it's mingled, right, but it has been distributed symmetrically. But when I talk about an electric field, no, so the positive side will be there, but the charges will take to the negative, right, no. So this negative charge will attract the positive charge and this negative charge will attract the positive charge, right. So polar molecules in dielectric without an electric field, this is, and polar molecules in dielectric with application of electric field. So these are the diagrams of the both the things, okay. So when we see that the center of positive charge will be displaced in the direction of the field and the center of negative charge in the opposite direction of the field, okay. So each molecule is said to be polarized. Now the polarized thing can be said. When we are talking about normal thing, it is non-polarized. When we take in an electric field, no, it is a polarized, okay. So as this molecule are polarized, surface charge will develop on each molecule, and this induced charge are in the opposite direction of the applied field, right. So this induced charge will develop an electric field, right, in the opposite direction. Obviously, due to charge polarization, the intensity of electric field in the dielectric reduces, and the value of actual field intensity will be E naught by K. Okay, so this is how, like, the non-polarized will be converted to polarized. Okay, so you can take a note of this. Okay, so the next question is, derive the formula for equivalent capacitance when capacitors are connected in series. Okay, so when we talk about the capacitance no, which are connected in series, this is how we will connect, right. So first point, suppose the two capacitor of capacitance C1 or C2, suppose we are taking two, are connected in series to a potential difference V. So in series combination, the same charge Q is stored on the plates of both capacitors. Okay, excuse me. Right, so both capacitors. So let V1 and V2 be the potential drop formed on the capacitance C1 and C2. When we talk about C1 and C2, like, charges will be stored same, okay, and the potential difference, potential drop has been taken as V1 and V2. So in the series combination, the potential drop is the sum of the potential, right, V1 plus V2. When we are talking about V3, V4, it will be V1 plus V2 plus V3 up to Vn, right. So what is Vn? V1 will be equal to Q by C1, V2 will be equal to Q by C2. So when we add both the things, V is equals to Q times of 1 by C1 plus 1 by C2, right. So therefore the effective capacitance will be 1 by C equals to 1 by C1 plus 1 by C2. When we talk about a parallel, it is C is equals to C1 plus C2 plus C3 up to Cn. So it is opposite of resistance only. Like, when we talk about a resistance of a parallel, R1 plus R2 plus R3 we will add on, right. No, when we talk about a capacitance, it is 1 by C1 plus 1 by C2, right. So this is the derivation of the capacitance in series condition, right. You can take a note of this. Done. Can we go for the next one? Okay. So the next question is, derive the formula for equivalent capacitance when capacitors are connected in parallel. Okay. So we have derived the for series. Now we are going to derive for parallel also. Right. Suppose the two capacitance C1 and C2 are connected in parallel. to the potential difference V. In parallel combination, no, the same potential difference V acts on this capacitance. Okay, so Q1 and Q2 be the charge of the two capacitors, where in the series condition V1 and V2 be the potential drop, and like Q will be same on the both the things. Here V is same on the both the things, and Q1 and Q2 are changing. So in parallel combination, the total charge will be Q is equal to Q1 plus Q2. So Q1 will be nothing but C1V and Q2 is nothing but C2V. So Q is equal to C1 plus C2 of V. So what is the effective capacitance here? C1 plus C2, right? So this is about the fifth question. You can take a note of this derivation, right? Then can we go for the next one? Okay. So with this we have concluded our electrostatic potential and capacitance short answer questions. Okay. So the questions you can see one more times, that is, yeah, derive an expression for electric potential due to a point charge, and when we talk about the thing, derive an expression for the capacitance and of parallel plate capacitor, right? So the next one is explain the behavior of dielectric in electric field. Okay, and then last two things are we need to derive an expression for capacitance in series condition and parallel condition. So this is one of the easiest chapter. Okay, so in options like you might, like in short answer questions, out of 6 you need you need to write some options questions will be there. So out of that you need to write some questions, right? So don't skip this lesson. This is one of the easiest lesson you can ever write right now. So don't skip this lesson, you can easily write this, right? So with this we'll end off this class and we'll meet with the next chapter in the upcoming classes. Okay, thank you guys, we'll meet in the next class.